the information from all the various parties involved. So I did want to add that because we'll kind of come back. So who am I? I'm with Trimble Navigation. I'm Robert Beck. I'm the Southwest Regional Sales Manager covering the Southwest from Colorado over to California. A little bit about Trimble. How many people recognize the name Trimble? All righty, good. We're doing our job. We're a company founded in 1978. We are the world's largest supplier of 3D positioning solutions. Went public in 1999, traded out on NASDAQ under the stock symbol TRMB. Spend approximately $80 million a year on R&D. Actually, I think that's even higher now. I think it's closer to 100. About 2,400 employees worldwide, over 500 GPS patents, and 80%, including Caltrans of the DOTs, utilize Trimble technology. One of the other things that affects us on the machine control side, we have a joint venture with Caterpillar. So that joint venture is called CTCT. One of my partners in crime back there will be up here after a while. But the purpose of that joint venture is to actually spend some of that R&D money that I just talked about to develop the machine automation process. So we have, with our partner Caterpillar, have the best in the machine process, and with Trimble we have some of the best technology minds. That's headquartered in Dayton, Ohio, and it combines technologies, patents, and personnel from both companies. So on to what I'm going to talk about here. I think we've got a laser pointer here. What I wanted to kind of talk about is the construction industry and some of the changes that have evolved and are continuing to evolve and kind of what we see. Question? No. Okay. You're just. So what we've seen here, and you'll look at this little timeline graph here, and some of these are fairly faint, but 1996, we had a greater government involvement in the feasibility, the planning, and the surveying. 2006, right now we're seeing that government is actually less involved, basically involved in the feasibility and planning stage, not so much in the surveying aspect. 2016, what we see looking forward is they're most likely going to be just involved in the feasibility, less in the actual planning and surveying. And so those responsibilities have to fall on somebody's shoulders. So we see those falling more on the architectural and engineering construction community there. So in 1996, you had the AEC community basically in the design portion. Now, 2006, we see them getting into the surveying and the planning, and pretty much still holding still with that going up into 2016. Surveying, pretty much so staying in the surveying field. Now, what we do see, one of the big factors here, is the actual construction market. So we see the construction market where in 1996 was in the estimating and earthworks portion. Okay, so that's what they did, is just doing the civil projects, the earth moving. But we see now and in the future that they're actually expanding what they do. We talked a little bit, had a little bit of a sidebar, where we see a lot of the contractors are going out and buying surveying and design companies, because now they can control more of the process. They can be more intimately involved. And that's why I wrote up there the information transference. Because right now, when you have these three disciplines, you have the planning, the surveying, the design, the estimating, the earthworks, those are all separate disciplines. Well, those disciplines don't necessarily transfer information from one to the other to the next all that well. And so what happens is we have what we like to call a digital wall. So between the planning, the survey, the design, and then over onto the earthworks portion, we have this wall. So you have the surveyors are doing their work and they're surveying. You have the planning and feasibility, and they're planning, okay, here's what we need to build, here's kind of what we're thinking. And then you have the design community, which is actually doing all of the design work using AutoCAD or Bentley or some type of software. But now that information is transferred to the contractor who's actually building the project, and how's it transferred? A roll of paper. It's like he takes that roll of paper and he throws it over the wall and, hey, go build it. So, hey, ma'am, what's your name? Back in the back. Nope, ma'am. Yes. Iris. Thank you. So you made a comment earlier about some of the accuracies of the design that, hey, we can design in AutoCAD and we can do all this down to this type of level, but it can't be built in the field. Well, the problem is, and so if you don't mind, I'm going to just touch on that point. Some of the issue is the contractors can build to that type of level, but the information is not given to them to be built in that type of level, because we're taking everything on a set of plans and throwing it up to them and say, hey, build it, because it's not necessarily designed that way. So if we can get past that and actually get the design firms and the survey firms to have as a deliverable a good 3D model, a buildable 3D model, I think we can do a lot better in the construction aspect. And I can say that I'm an old engineer, ex-engineer, so I can step on myself a little bit there. My job was to produce a nice set of plans, and they plotted out very nicely, and they got approved and built. So we see the construction industry actually expanding to take on more of the design survey aspects, and then as well as the afterlife, the maintenance of the projects. So the long term. So all this comes together as part of the construction continuum, because the construction is not just we're going to build something. The construction is from feasibility all the way to the end of life. So that's the whole process. And so that's what we, Trimble, are kind of focused on, is the whole process. And can we offer products and solutions to the construction industry, to the construction continuum, to help solve some of the issues of the transference of data. So yes, we are a great hardware company, but we also make great software. And with that, go through a little bit of the different divisions here. Okay, maybe not. Maybe it just wants me to stay up here. Okay, there we go. So part of that, back on that feasibility, we have a company called Quantum, based out of Australia, and it is a route optimization type of software. So we had a presentation earlier on some. Basically what it does is it takes into account a lot of the corridors, the alignments, the construction cost, environmental restrictions, existing features that need to be avoided, the legislative obligations, all the aspects, and looks at the optimized, and looks at the route and then optimizes for it and said, okay, where is the best place to put this? So we do have tools to help in that process. The survey process, once again, we have the tools. This is where most people know the name Trimble, is providing the tools for the geospatial community. So we can go in there, we can not only survey the land, but we can survey the bridges, give detailed 3D models of what was surveyed in through high-definition scanning capabilities. Oop, wrong way. Design software. Excellent design software, once again, to help in that transference of information to go from the survey community, then into the design community, and then straight out to the field, and that surveyors can also use to estimate from. Great visualization tools. Questions so far?
Does it have a cost capability? Does it generate an estimate, or
no.
Provide
this is no. This will provide the quantities. The problem with the cost estimate is they're so regional. There are databases, the means databases, and different things out there that contractors use. But A, they're regional, and B, that information comes from contractors themselves. And so for contractors to turn in and say, okay, well, here's what we're typically bidding unit cost-wise, the data might not be totally accurate. Yes, sir?
Are you seeing less resistance to 3D data from the designers and through the whole process? Or, because that's where I see a lot of the bottleneck.
That's the biggest bottleneck.
Why is it? Isn't it to their advantage?
No.
Okay, tell me about that.
There,
It's more work to design in 3D.
absolutely, it is.
Maybe
There.
we should pay them more.
Well, so here's some of the challenges. I mean, this is, and I'll go back to my days as an engineer. My job, I got paid. My job was to I built Payless shoe stores, Napa Auto Parts, and some Home Depots all around the U.S. So working with the local governments to actually design it and build it. But my job when I worked for Genuine Parts Company or Payless or whomever was to design a set of civil drawings that got permitted, that I got a clearing and grubbing permit from. So therefore, the owner of the property knew that they could buy the property because they wouldn't buy it until they know that they could build what they wanted to build. Once I had the clearing and grubbing permit, job was done. I mean, I had to make sure I had sidewalks up front if that's what they called for. How many parking spaces? Did I have handicap ramps? Those types of things. I didn't design something necessarily to be built accurately. It had to print off nicely. And so that's what the civil engineering community does. It's their job to design something and not necessarily take into effect. We always prided ourselves that we did, best quality, okay, or TCM, total quality management, something like that, and value engineering. Well, that's not necessarily what the finished product always was.
It's your definition of quality.
Huh?
It just depends on your definition.
It depends on your definition of quality. So today, the software companies, Autodesk, Bentley, ourselves, will make great softwares that the design can be done in 3D, but it's actually changing the engineering community's aspect that, hey, you can design in 3D, and it's not going to cost you that much more. But the problem is this is the way we've always done it, and it's slow to change.
In the building sector, at any rate, one of the constraints has been where they haven't changed commercial terms is that, well, an architectural firm, for example, they actually make their money generating documents,
That's right.
right? Not producing design.
Mhm.
And if you and basically BIM takes away the drawing problem, right? And you extract drawings from the model if you need 2D representation.
Mhm.
And so they really have a profitability problem, but that can be solved with a change in commercial. I mean, you still need them, right? They're doing something valuable. You just need to change the terms so they can stay in business.
And it has to, the scope of work has to change, and it has to change from the owners of the projects, from the DOTs, from Home Depot corporates, Walmart corporates. That's where the change has to come from, is they have to understand the benefits of using machine automation. Okay, we understand that we're going to save 30% of time on this project, so therefore me, as an owner of Walmart, I'm going to get my doors open to my store sooner. And that's where the payback is. So they have to change and go to their architecture engineering companies and say the deliverable is not a set of plans. The deliverable is actually a design file, something buildable. We have contractors right now, you guys are a prime example, that are reverse engineering everything off of the set of plans or the CAD files to look for obstructions and to look for projects in 3Ds. Is it buildable? Am I making a set of drawings that is actually buildable out in the field? A constructability analysis is what some of them are calling it. It's after the fact, and that's why all those RFIs and everything that slow the process down are popping up.
Here in California, the signed and sealed paper copies are the professional
That's it.
work product.
That's it.
The digital file is a working
Yep.
file.
Thank you very much for saying that.
Legal and liability issues that CELSA and lots of professional engineers and surveyors would have to change a lot in order to get to that point.
That's right.
I've been talking of yes, it's a big we. There's discussions going on with insurance companies, professional design insurance companies.
I threw it back there. That's why I got rid of it.
An advantage and the reduction of risk on projects and improvement in quality. And so why shouldn't we change the liability provision to recognize that?
And that's
It's happening now.
And it's going to have to change if we're going to get past this hurdle, because right now, yes, as you said, it's the construction documents that are stamped, sealed, dated, initialed from the PE of the project that says This is all, this has my name on it, that's all I'm approving to. And the release of that 3D data, that actual design data that a lot of them have but are hesitant to release, because if they give it, well, is that signed, is that dated, were there changes, were there modifications? There's a risk associated with putting that digital data out there, and then if something's built, who changed what when?
And additionally, from the business and professions code, especially the law, losing control of that data and having it modified, as you just alluded to, is required to be under the responsible charge of an engineer or a surveyor. And so I liked you saying that construction companies are lining up surveying engineering firms, but they believe they still have to be in the process separate from any which a construction continuum had kind of identified as being eliminated from part of the process.
Anybody looked at signing the data electronically? I mean, it's
I
these
heard-
things technically they're doable, but
Yeah, and I heard that was a thing that was, with the electronic signatures. I heard that years and years ago. I haven't seen anything come to fruition regarding that. That's one thing. If you're talking about lean construction, I've been doing this for 10 years and preaching the gospel, and it's this transference of information. It's we are a digital society, and we want information, and we want to correct, and we want it now, and that's how we're going to get information, or that's how we're going to build things better and faster. And so, how do we get past this? Because right now, as I showed before, we had those walls. We've got these true digital walls that are there between the different disciplines. And if we can get the disciplines working together, I think we're going to see, lean construction truly come together, because it's all driven from data. So that's my soapbox. Yes, sir.
Question about this quantum company from Australia.
Yes.
There was Cosmos mentioned there
Yes.
in the feasibility stage. If they have solved all those problems and they come to Finland, so I'm out of business, I guess.
I don't know quantum that well. It's not my area of expertise. Levon, do you know more than I do on quantum?
I think they
And
have
some of the
a
features?
product similar to yours. Yes, and I'll stop there. Knowing
Yeah.
what you want.
Yeah.
Doesn't mean you're out of business. You're just not a monopoly.
You just have a competitor. That's it.
Really?
you're not the next Bill Gates.
Competition drives innovation. Competition drives innovation.
Another question.
Yes, sir.
That, if you have a construction continuum, why don't they check this information to other construction phases also? Only they concentrate on the feasibility study. Or,
Are you talking about quantum vision?
Yeah.
yes.
That's a good.
Why aren't they checking further to the surveying, designing, construction phase?
Once again,
That's a good question.
that's an excellent question.
Before we acquired them, of course, they were focusing on their product, and that's what they're doing right now too.
But we obviously we Trimble have this vision, this construction continuum vision, and so we are look for talent, and we look for not just a product, but more of a greater aspect. So, Terra model went through that. Oops, once again I'm going the wrong way. Estimating. So this we have tools to assist the contractors in the estimating phase. Because right now, most of the contractors, once again, are being given a set of construction documents, big roll, and hey, I need to find out so I can put my bid together. How much earth am I moving? What's my cuts? What's my fills? What's my total concrete? So I need to be able to figure those out. So we have the tools to be able to assist them to do that as well. So my favorite part is the grade control systems. These are the 3D grade control systems, or GCS as we call them. This is where the contractors can make the money. Once again, taking that design data that was done by the engineer, we can take that 3D model, if it's a 3D model, load it directly into the cab of the machine, just with the data card, and we put either some type of positioning technology, whether it's a GPS antenna, whether it's a optical total station, whether it's laser or some type of positioning base, and then we can drive the machine itself. So we still have operators involved. Operators drive forwards, backwards, left, right, but we can tell exactly where that operator is at all times, what the design needs to be, where the blade currently is, and then drive the cutting edge to what the design grade is. So therefore taking out, right now my worst enemy is grade stakes. You have surveyors going out there at $110 an hour to put a piece of wood in the ground so an operator can look 50 feet in front of him and go, oh, well, I have a 3-foot cut there, 50 feet over here, I have a 20-foot cut, so it's probably doing something like this. Well, geez, 50, grade stakes every 50 feet, that gives me a lot of information. Now I can put the design file directly on the machine itself, and I have information every inch I move in every subsector of that inch. So I have an infinite number of grade stakes. Just, you talk about productivity enhancers, that's just huge because now I have the information I have everywhere. I don't have to stop if grade stakes aren't there. I don't have to stop what I'm doing, wait for a surveyor to come out, who might be there later today, might be there tomorrow, we'll see, to get that information. We also have the fleet management. Part of the construction continuum is supplying that information of where's my equipment? How fast do I have a haul truck, a asphalt truck? How fast is he driving? Is he a danger? Is he dropping off asphalt someplace he shouldn't be dropping asphalt off? What's his route time? What are the cycle times? What's the maintenance on the equipment? So supplying all that information to owners of companies so they can better utilize their equipment. We had a great story of a customer who put the systems on. We talked him into it, and he said, we kind of know how our equipment's being utilized. Okay, that's good. Let's put it on. Let's just kind of see. We can run reports that are called idle time reports. Okay, is your equipment not moving? Well, we put it on there. We got a call from him about a week later. He goes, one thing I realized, we have our equipment sitting in our yard idling for an hour every morning, waiting to be loaded. We got the guys coming in at 5 a.m. They don't leave until 6. Why do we have them there an hour early? A lot of them are being paid overtime, and the machines are running and idling, burning an extra hour's worth of fuel. He goes, it's something we've always done, but until I saw it on a report, it just never hit me. So once again, giving the information so people can make intelligent decisions. To build construction. So once again, simple tools such as pipe lasers. I need to put a laser in a pipe because I need to make a 2% fall. Simple tools that help the projects be built faster and more accurate. Layout tools. We need a position. When I say we've got a lot of concrete buildings being put up here. Well, punch outs have to happen. Anchor bolts need to be set. And right now we got a lot of contractors out there pulling tapes. Well, let's be smart about it. Let's actually take the CAD files that have all the anchor bolt positions, have all the punch outs in them, and lay them out with the total station so we can lay out a lot more accurately per day, eliminating a lot of the waste. I'll get that up and down button mastered one of these days. The maintain and operate portion. So the end of life. We have a company called Meridian Systems to help manage a lot of the end of life or just the day-to-day operations. Do you know more on this, Levon, on Meridian than I do?
Well, I heard Primavera mention earlier that you use them. They're a competitor of Meridian Systems. Also can be used for project planning. Before that, where they really shine is in the maintain and operate phase.
Okay. Yep. So it's typically the maintain and operate phase. Once again, putting all the information in so we can better make decisions along the process. Some of the challenges that face contractors today. It's the data and the collaboration. Can we get data to make the decisions or to run our machine automations? They want to be more profitable. They want to do things better and more accurate, but are sometimes hamstrung on the actual information that's provided. One of the challenges right now is the price to move a cubic yard of dirt really hasn't changed in 20 years, what they can actually bid it for. So they have to find better ways to move that cubic yard of dirt. Right, guys? The cost across the board, they're increasing. Fuel, labor, everything's going up. But once again, the price their bid price to move that cubic yard hasn't gone up. So they got to be smarter about it. They need to stay competitive because it is a competitive field. It all comes back to productivity and efficiency. Trying to do what they can do more cheaper and better. You have the labor shortages, employee training and retention. This is a thing I know that Caterpillar is very strong on. Is trying to provide products that are more easily trainable. They've got a new motor grader coming out here. I don't want to steal your thunder on the M series. So you can actually get an operator in there, and he doesn't have to be a 20-year operator anymore to be able to operate the thing and be efficient at it. So, and that's where a lot of our grade control and a lot of our technology comes in, is that we can train people to move dirt better and more accurately, but they don't have to have the skill set of a 20-year operator. We can go in there, we can teach them how to operate. You still have to be an operator, know how to effectively move dirt, but they can go in there and flick the automatic switches, and now they're grading that $0.50 a quarter mile. Environmental safety concerns. We need to stay out of certain areas. We need to do certain things so we can actually, plug those into the systems. So there are warnings and advancements so you don't get fines and everything else. And the equipment versatility makes different types of equipment more versatile. We can do more with what we have. So the benefit of Trimble's construction products. Increased collaboration. The data flow is a lot better from all the different aspects. Less rework. In-field information for quicker decision making. We can make decisions now instead of having to go back to the office, analyze, have a meeting. We can see all the information directly in the field. Lower operating costs, improving material yields, flexibility to make decisions, overall productivity, and once again, increase the bottom line profits. So somebody earlier for the last slide was asking, so what's the proof? It's almost impossible for manufacturers such as ourselves to have proof because there are competitive advantages to utilizing the technology, and so that's not easily gained. But if y'all can read that in the back, I do have the ability to use this. That's an earth-moving construction site by Suka Construction in Southern California. Suka's Construction's GPS technology reduced the grading schedule by 30%. That's lean construction. Questions? Comments? Yes?
After you have made your process with 3D control systems, is it possible to save the data, testing data?
Yes.
That has been done.
We've got a great little feature. It's called terrain logging. So you can go in there. You can actually turn on terrain logging wherever that blade is. The trick is the blade needs to be on the ground. If it's up 3 feet up in there, it's going to log data 3 feet up in there. But if that blade is on the ground, it's logging the data. Where is it? In a text file. We have a two-way data transfer. So one of the things that we talked about briefly is I can be in the office using the software. I can see my equipment out in the field moving around on the screen. And then I can go into that machine and I can grab that data logging file. And I can pull it off of the machine because he might be 5 hours down the road and I want to see, what did you do today? Well, I can pull that data logging file off of the machine into the office, dump it into either TerraModel or Paydirt, and I can run volume analysis. What did you move today? So if I have to make decisions based upon, or pay schedules or anything else based upon productivity, yes, I can actually log the data out in the field and bring it back in. Any other questions? Yes, sir.
What is the market situation?
Speak into my chest.
You like that line?
Yeah, I did like that line.
What is the market situation in United States? How many machine control systems are used?
I don't know in the U.S., but what I can estimate is here in the Bay Area, we probably have 250. Within the kind of Northern California Bay Area, 250 systems alone. Tom, do you have any estimates?
I can comment on the number of our machines that over the last, since we started getting into this, that are ordered from the factory, brake control ready, plumbing ready to go. And it 4 years ago it was in the single percent, and on certain machines it's up to, on the more it's up to 40% of those machines have been ordered with it. It doesn't mean it's getting GPS kits on it.
That's right.
But it means the dealers are starting inventory on certain models, the midline dosage and stuff. Probably average stuff from our factory is closer to the 18 to 20 on the main models. But I mean, it gives you an idea. Again, that's not adoption of GPS, but that's adoption of the concept that eventually we want to put it on. I think we've heard that you think the market's at 10% maybe in the U.S.
No. That's maybe machine control in total.
Right.
So machine control, there's two different levels. There's the, as we call the 2D or the traditional machine control. That's your laser-based, sonic-based. Okay, so that's cutting a flat plane or some type of plane thereof without using a design model. We probably estimate that it's probably in the neighborhood of about 7 to 10%. Okay, now actually 3D machine control, we're estimating it's maybe an adoption rate of about 1% right now. Now, not all machines are always going to have 3D machine control. It's not a tool for every machine, or for every machine within that. You're usually going to have lead machines. But having an adoption rate of 1 to 2% in that arena, we're barely scratching the surface. Barely scratching the surface.
And is that partly driven by the lack of 3D design models?
I think that has a lot to do with it, is the adoption, because the contractors know this technology exists. And they're looking at it and saying, okay, well, how much work do I have to add back in the office? What do I have to do? Is it truly a plug-and-play environment yet? No, it's not. There's still, you have to reverse engineer, you have to do calibrations, you have to do a lot of things involved. That's where our partnership with Caterpillar is great, because they can make the machines come off the line, and then we focus on some of the other aspects. So I think it'll get there, but we have to drive the engineering community and a lot of the development community to adopt that. Yes, sir.
Related to that somewhat, I'm not sure what the design, what the life is of a typical machine.
Yeah, the life. Now, if you're using it for 3D machine control for machine automation, usually about 3 to 4 years we see them, because that's when you start getting a lot of slop in the machine, some wear points depending on the usage, and so then they'll migrate and put it on another machine that's tighter.
Well, I was thinking, if you're contacting, you've got to talk to your plant. It's not a time it's kept around for a long time.
Yeah, but that's the great thing with Trimble is we can put it on anything. So whether you have an existing machine in the field or other machines, we can stick it on at any time. Yeah. Oh, absolutely. Oh, I've retrofitted 1969 dozers. Now they're not automatic, but we can put it on so they have indicate systems and they can operate. Absolutely. Right over here.
I just wanted to make one comment, was that not every project is suitable for machine control, and I think a lot of contractors are also having to figure that out, where that profit margin is, and I think that will increase in the future as things get better, but right now, small jobs, it just may not pay off.
It may or may not, depending. I had a contractor that I used to work with, and he has machine control, has the 3D, does airport work and subdivisions, but he had to keep his crews busy and had a McDonald's and put his D8T out there with a GPS system just to knock out a McDonald's. So I've seen him used.
There's a lot of factors. I mean, if you think about it, these things started getting commercialized. Trimble came in is it 99 or 2000 that you guys started with your 3D system?
98,
Is it on? Okay.
about 98.
And if you think about when it was developed and commercialized, also then look at the economy, at least in North America during that time, has pretty much since 2001, 2002 been booming. And contractors, and you guys can attest to this, there's been a lot of work to do and have been pretty busy just getting done the work that they need to get done. The areas of the country right now that are starting to slow a little bit, and all of a sudden it's getting a little more competitive to get those jobs, you're starting to see these types of technologies spike pretty high in those areas because the progressive contractors that have been doing it for the last 4 years are in such a better position now that it's slowing a little bit and getting more competitive. So it's going to be it was an interesting time for the technology to come, just where the economy was. And I think the proof is going to be probably in the next 5 years, the adoption rates, at least we think, are going to spike up pretty considerably.
So one last point, just as a shameless plug while I'm in front of people. We have our end users conference, Trimble Dimensions. It's an end user conference where people can come. You don't have to be an actual end user. It's in Vegas this year. November 5th through 7th. Jump on our Trimble website. It's a great place to come and learn about all the technology. Spend 2.5 days just immersing yourself. Tom even comes.
It's a great conference. I plan on coming again.
If you're invited.
Thanks, Robert.
Thank you.
Sure.